Hi, everyone. My name is Andy Goodmans. I'm the VP of Analytics and also run Elasticache at AWS. Thanks a lot for joining us today. You clearly like analytics and data lakes because you came to the room that was the most distant room in the building. At least I had a hard time finding it. What I'm going to do today is talk a bit about data lakes, talk about our analytics portfolio, but I'm going to focus mostly on some of the new announcements we've made and some of the new things that have been coming out around these services. And we're also going to show you a couple of demos of some new features that we've launched. So the new reality in analytics is that there's a huge explosion of data, which is creating a lot of challenges. On one hand, companies are trying to become digital-first companies, trying to democratize insights across the employee base, but then you've got to deal with this huge data scale. And not only does that potentially lead to a lot of incremental cost, but it also leads to a lot of incremental complexity. And so that's a problem that we are definitely trying to solve for you, and we're going to talk later on some of the things we're doing. There's also an explosion of personas. As we're trying to democratize insights, it's not just the business analysts who are trying to get access to the data. It's data scientists, data analysts, application developers. Really everyone in the organization is trying to make better decisions and trying to make better data-driven decisions. So that really means that we as AWS have to be a lot more thoughtful about the different personas who are trying to use our systems and making sure we really tailor to everyone. We also have to think a lot more about security and compliance and making sure that while we help break down those data silos, your organizations can also make sure they manage data access and make sure that not all data is accessible to everyone. And then last but not least is making sure that insights are more real-time. Gone are the days where you had a nightly ETL job that brought all the data into the data warehouse, and basically your insights were 24 hours delayed. A lot of our customers want to make real-time decisions, and actually even as I'll talk a bit about Redshift later on, it's not just the data warehouse anymore. A lot of these workloads are operational in nature, trying to make faster decisions, so these are kind of things that we have to be thinking about. The first thing in building more context around your data and having smarter insights is actually being able to see all the data in one. And so in the past, you've had a lot of data silos. And just to give you an example, if you want to derive insights from online buyer behavior, right? You need to have your purchasing data, which would traditionally be stored either in your operational database or your data warehouse. But you also have to look at your clickstream data that is coming from the website. The owners of those data sources may be two very different parts of the organization. The sales data may be in your CRM. The clickstream data belongs to folks who are running the website. But the real insights come from actually merging that data, right? So it's not just reporting on sales, but saying, hey, out of the users who went to see this specific page on the website, right, how much did that page influence conversions to revenue? And so, getting those smarter insights really means we've got to break down those silos. And there's nothing better than the data lake to be that starting point for you. And I'll talk about why the data lake is that good starting point, but it's really a central place where you can start storing your data and then, of course, take it from there depending on your use case. So the way we think about the data lake, it's a single data store, right, where you can store all your data. It is extremely cost effective. I'll talk a bit more about that in a couple of minutes. But the problem you have right now is, the petabyte is really the new terabyte. Terabyte is the new gigabyte. And it's great to have all this data, and there's so much insight you can gain from that data, but it's very, very expensive, right? And so, what we try and do at AWS, of course, is to continue to support you in innovating, but also making sure we help you innovate in a cost-effective way. So we'll talk a bit about why the data lake is really that cost-effective way of doing things. Number two is because so many different personas need access to the data, different applications need access, you really want to have an open data lake. Not something that's proprietary with proprietary APIs, but making sure you have open formats, whether those are analytics optimized formats like Parquet or ORC, just to make sure that you can really leverage that data as broadly as possible. And then you'll have different use cases, and we'll talk about some of those use cases later on. But we don't believe in a one-size-fits-all solution. We do believe you need purpose-built solutions to make sure that you can get your job done as effectively as possible. So S3 is the anchor point for a data lake for most organizations. We have more data lakes on S3 than anywhere else in the cloud or on premises. And so why S3? First of all, it's a virtually unlimited storage space. You can pretty much put as much data as you need on there. Number two, it is extremely durable. Yeah, we have 11 nines of durability, multi-AZ. It's extremely feature-rich. I won't go into all the features, but there's just a lot that you can do with S3. Cost is very, very important. As we talked about, you want to retain your data, but you have to start retaining the data in the most cost-effective manner. S3 has a price point of roughly 2 cents per gigabyte. But we also have Glacier, which is a price point of 0.4 cents per gigabyte. And we have Glacier Deep Archive, which helps you store data at around 0.1 cents per gigabyte. So if you think about the data lake as your anchor point and also acknowledge that not all data is created equal, some data you kind of want to keep hot because you're going to do a lot of analytics on it. Some data is for compliance reasons, so you really don't care about quick access to that data. You just want to store it in the cheapest manner possible. S3 gives you those options. And we have S3 intelligent tiering, where basically based on your access patterns, you can build rules that says, if I'm not accessing my data for like more than 30 days, if I'm not accessing for more than 30 days, I actually want to tier that into slower storage that's going to save me a lot of money. Some other things that people don't really think about, Andy mentioned it in the keynote yesterday, we have really awesome networking. A lot of our instances now do 100 gigabit per second. That is faster than some of the dense storage compute nodes that we still have on AWS. So you're kind of talking about network bandwidth that is really incredible. And S3 can get to that network bandwidth. So when we build systems, we can actually get pretty much a full 100 gigabits per second off of S3 if we need to. And a lot of our services are taking advantage of that. So the way we think about our portfolio is we start with S3 as that data lake. But if you just take S3 and you throw some files in there, I would say it's a data swamp, not a data lake. And and our goal is to get you to a true data lake. And we'll talk a bit about what that data lake looks like. But making that transition is very, very important. And so on top of S3, we have services such as Lake Formation and Glue that kind of help you transition from that data swamp with a bunch of stuff to highly curated data, indexed in analytics optimized formats, cataloged so that it can be discovered, security being configured, and so on and so forth. You heard some announcements yesterday, right? We talked about Aqua in Redshift in Andy's keynote. I'll talk about that a bit later on. But we're also thinking about, compute and storage separation is great, and we have 100 gigabit per second networking. However, as your data scale explodes, your demands are also increasing. And the more real time you want to get, the faster performance you need. So we are, doing quite a lot of exciting work to what I call disaggregating compute and actually starting to push compute closer to the storage so you can actually get the full benefit of the innovation that's happening on flash and NVMe SSD drives. And then we have a very broad, complete portfolio of analytics offerings, and we're going to go through some of those today that can interact with the data lake. So Redshift, EMR, Athena for ad hoc querying, our machine learning products like SageMaker integrate with the data lake. And what I'm going to do today is kind of take you on a journey through some of those products. We're not going to go super deep, as I wanted to focus mostly on some of the new things that are happening in these services, and then also show you a couple of them. So how do we think about the services when we build them on top of the data lake? First of all, these are cloud-first services. And what does that mean, cloud-first services? There's certain things we can do in the cloud that were pretty much impossible to do on premises, right? We can be very elastic. We can run hundreds of nodes if we need to for single queries, if that makes sense. Like Redshift Spectrum, does that sometimes. There's a lot of things we can do and think about as we're building these services in the cloud that would be very difficult to do on premises. Number two is we don't, as an organization, believe in a one-size-fits-all. There is a certain appeal to one-size-fits-all because it's sometimes easier, but we also feel like that actually introduces limitations. The reality is we don't want you to compromise on functionality, performance, or scale. And when you have one-size-fits-all solutions, you usually have to make a compromise on at least one of those dimensions. So we do try and make sure that we are well integrated into a single view of the data and have a single view of security and governance and so on, but then also give you a lot of opportunity to use the engine that you want. And that engine may be an engine that we provide, or it may be an engine one of our partners provides. And so we're also making sure we're enabling a very robust partner ecosystem around analytics, so you can truly have a lot of choice in what solution is the best for you. And then the third is just making sure we're truly giving you a fully managed experience. One of the most difficult things, whether that's on premises or in the cloud, is managing these systems. And especially in analytics, where you're dealing with a lot of data, a lot of scale, a lot of memory issues, queries are big. When you're self-managing software, whether that's things like Elasticsearch or data warehousing, if you've been doing that, which I'm sure some of you have, you've also felt quite a bit of pain. So we do try and make sure that we take some of that muck away from you, and the undifferentiated heavy lifting is something that we do. And we're up 24/7 making sure that your system is actually working. And we want to make sure that we're your single throat to choke if something isn't working on your system. So we've got a huge set of customers, running their data lakes analytics on AWS. I'm not going to go, through many of them, but like FINRA basically is there to catch, fraudsters on stock exchanges and so on, and they analyze, exabytes. I think petabytes, I think even exabytes of data on AWS with EMR and other systems. Electronic Arts is using data warehousing, and a lot of the gaming clickstream is basically being analyzed by Redshift. And we have, lots of use cases, whether those are, in the life sciences, around drug discovery and big data analytics. McDonald's that is using us is using Redshift for analytics. So very important set of customers, and I think the most important piece about it is, given we're extremely customer obsessed, and as a company, we're always working backwards from customers, having this customer base really helps us innovate on your behalf. And the way we think about innovation, I would say, is kind of twofold. Andy talks about it also quite a bit. 90% of what we do is really just listening, very tactically to what you're telling us and making sure we iterate and we make things better and we help you with new features and new capabilities. And then I would say 10% of that comes from just having a very deep understanding on the kind of pain points that you have and the challenges you're facing, and then try and think about how we can change the game for you. So in yesterday's announcement, I'm going to talk about later on, Aqua for Redshift. That's an example where we really listened to our customers, but our customers weren't telling us exactly what to build. but we kind of understood, like, scale and cost and performance are just becoming very, very challenging with this explosion of data. So we need to do something to make it a lot more affordable and manageable for you. So as I mentioned, you want to go from data swamp to data lake. The right place to start there is with AWS Lake Formation. We announced the general availability in August 2019, so not too long ago. And Lake Formation is a really good starting point for you to basically, ingest your data into the data lake, make sure you cleanse the data, catalog the data, and then you can also configure security around the data, including column-level access control. And by the way, when you put your security policies in Lake Formation, including column-level access control, engines that are sitting on top of that, like Redshift, Athena, and EMR, we actually honor that. And so it gives you kind of that central point to configure that. Lake Formation leverages Glue. And I think about Glue as kind of almost two different products. There's Glue Data Catalog, which helps you catalog the data, and then Glue ETL. Glue ETL is an ETL product that we built with more of a developer mindset. It basically helps you ingest data from lots of different data sources. And then we use Spark. It's basically, think about it as a serverless Spark that works on semi-structured data. And we generate Spark code for you. Now, you don't have to touch that code. It will work as is. But it's kind of, think about it as an open ETL that if you want to modify, you can actually go into the Spark code and make some tweaks. And we will run that for you as a serverless Spark engine. So you don't have to worry about managing servers or managing your ETL jobs. The other thing that Glue will do is it will actually output that data into an analytics optimized format. So very often that will be in a Parquet format. And so that's how you go from your raw data in the data swamp to having data that is cleansed and indexed. So it's basically analytics ready. And being an analytics format will actually do two things for you. One is it's going to give you much better performance, but number two, it will also save you cost. Because once you're in analytics optimized format, we have to touch less data. And with some products like Spectrum and Athena, you basically pay based on the amount of data that we're touching and scanning. And so doing that will also get you into a much more cost-effective situation. I also talk about some of the other ways you can get data into the data lake. I apologize for not having the logos up here. We had a bit of a technical problem. But we have, our streaming portfolio is really meant to help you collect the data from lots of different sources and then bring that either into the data lake or bring it into Redshift or Elasticsearch. And so we have multiple options. Amazon Kinesis Data Streams, which is basically a managed streaming technology. You can kind of set how much of it you want, and then we manage that for you. Kinesis Firehose, which is completely fully managed, serverless, and Kinesis Firehose automatically will ingest the data into things like Elasticsearch, Redshift, S3. So it's a really convenient way for getting data in. And then in Kinesis Data Analytics, which is somewhat confusing because people don't always remember what is what. Kinesis Data Analytics is really, I would say, has two key options. The first one is giving you SQL support on streaming. The second one is it's basically a managed Flink, Apache Flink. So if you're a Flink user, how many of you are using Flink? Not too many? Okay, Flink is basically a rising star. It's an open source project, open source streaming project. And so the other option we have here is actually we manage Flink for you, and we allow you to deploy your Java code onto the managed service so you can actually do your own streaming processing. And then, as you may know, we also we also support managed Kafka, which is open source, which helps you use Kafka, makes it easier for you to basically consume Kafka. Some of the new things that have been coming out on the streaming front, just very lately is we've added VPC support, which was a much requested feature in Kinesis Data Analytics, especially important for Flink users who want to both be able to reach into their VPC for inbound data and outbound data. We also just released the Prometheus support for managed Kafka. So we're basically emitting Prometheus metrics, and then from there you could also use those metrics in other products. Like New Relic has just published a really nice blog post on how you could use this to then get the metrics into New Relic. And then last but not least, made it very, very easy to wire Kafka and Flink together, and that's also based on the VPC support that we've introduced. So a lot happening on the streaming side. I think we're seeing an increasing amount of our customers bring data in through streams. And so this is an area where you're seeing a lot of progress from us, a lot of investment, and we're definitely interested to hear from you what else you would like us to do. One service that I'm super excited about that we just announced a few weeks ago is AWS Data Exchange. One of the most difficult things, whether you're doing machine learning or just a business in a certain vertical, is getting access to third-party data sources. And for any of you who've actually done this before, you know that you got to find the right vendor who's actually selling the data. You got to spend a lot of time negotiating contracts. It's a very, very difficult and expensive process if you need to get data sets. So what we decided to do is basically create a marketplace around data sets and really help democratize access to data sets. And so we have basically publishers and consumers, and we already have over 1,000 data products on the data set, on the data exchange coming from 80 data providers. And that includes data providers in healthcare, financial services, and so on. And to make it super easy for you to find and subscribe to data sets there, and if you actually have data sets you think you can monetize, you can also become a publisher there. So just making it super easy. And by the way, if you're just looking for random data sets to play around with, if you're, I don't know, trying to experiment with machine learning and so on, there are actually also some free data sets there. So not everything is paid. There's also free data sets there. Some companies also make subsets of their data sets available for free, so you can kind of see some of that. So we're just super excited about that because analytics is all about building context. And a lot of that context is going to come from your data, but very often there's third-party data that can enrich your data and give you much, much better context. So talking a bit about Redshift, Redshift is our cloud data warehouse. We have tens of thousands of customers. It's the most popular data warehouse in the cloud. Obviously, you saw quite a bit of coverage of Redshift yesterday. I'll talk a bit more about that. But we are basically, the way we look at Redshift is it's not just a data warehouse anymore. The nature of the workloads are changing. I mentioned it before, a lot more operational workloads, a lot more hybrid data lake and data warehouse. We called it the lake house. It was actually one of our customers, one of our financial services customers who kind of gave us that idea. They're like, we use your architecture and we call it the lake house internally. So we kind of like that idea, so we've started to use that name. But really a big emphasis of ours is how do we fit in, how do we help you break down those data silos with the data lake, the data warehouse? I'll talk later on about federated querying, and we've extended this to the operational data warehouse. How do we make sure you get the best price performance? So it's not just about performance, it's also best price performance. How do we, when you commit to a piece of hardware and you're buying resources, how do we make sure we really extract the maximum out of it? And at AWS, we're consistently trying to make sure that we're giving you more value for your money. And so there's a lot of innovation happening on this front, and I'll talk about some of that later on. Of course, security and compliance is also a huge area of focus for us. So as I mentioned, Redshift, the most widely used cloud data warehouse, tens of thousands of customers, and we're learning a lot from our customers and improving the system. We have a lot of instrumentation across the fleet. We also use machine learning in how we look at queries, classify queries, and think about the workload. So we've really been able to make a huge amount of progress on the service by actually learning from how you are using the service. And in the past 18 months, we've had over 200 new features and functions that we've released. Interesting thing about yesterday's keynote is we actually had 10 releases lined up for Redshift. And obviously, Andy couldn't be on stage and talk about Redshift for a whole hour. So 6 of those were actually released before reInvent. So that just gives you a sense of the velocity that we have in Redshift and how much innovation we've driven. Just a few things I'll call out in the past 2-3 weeks that we've announced. We have a new console experience. We announced materialized views. We released the support for spatial data, and you're actually going to see a demo on how you can leverage that spatial capability in your applications. Just in the past 6 months, we've made a 2.35x out-of-the-box performance improvement on Redshift. So those are some of the things that we actually had to take out of the keynote because it was getting too long, that we've already announced in the past 2 to 3 weeks. So if you're using Redshift or thinking of using Redshift, I highly recommend you look at our What's New, and you're going to see a bunch of things that we actually launched around Redshift. So super important space for us, a lot of innovation, and you're going to keep on seeing that momentum around innovation. One of the things that I'm really excited about is the federated querying experience that we announced yesterday. So we already had a capability, as I mentioned before, to query across the data lake and the data warehouse. And Redshift is just awesome at processing queries at scale. We can do this at petabyte scale. But as we were talking to customers and we're thinking about how do we help break down data silos, customers were frequently putting, years of data in S3 in the data lake, and then maybe the past year of data in data warehousing. But there was still kind of the ETL piece in many use cases where they would ingest the data, every hour, every day. But as customers wanted more real-time insights, they wanted to make sure that they could actually query that data in a way that gives them the most up-to-date answer for the given time that they're running the query in. And so by extending Redshift also to operational databases, and we've started with Aurora and RDS Postgres, you can actually query across all 3 in a single query and get an up-to-date result on what's happening with your business. And unlike the federated querying that you've probably seen in the past, where vendors take a query, a subquery, and they ship it to the operational database, and then the data comes back as is, and then query processing continues, one of the secret sauces in Redshift is we have a very, very sophisticated query planner. Right, so if you have a huge query with subselects and so on, and one of them is going to the operational database, but we can learn from the rest that we could actually push down additional filters. We will actually rewrite that query and push it down in the most optimal way. So we've really built this in a way that will give you the highest performance, and you don't have to think too much about how you're writing your queries, because we're going to try and make sure that we minimize the amount of work that we ultimately have to do in the system. The other thing we announced yesterday are the new RE3 instances. It's kind of 2 announcements in one. The first announcement is it's just a super awesome instance. It's lots of local SSD, built on a Nitro system, so very high network bandwidth. The hypervisor gets offloaded, so you're basically getting near bare metal, or basically performance indistinguishable from bare metal. So just a super great instance. But the other thing we also did was to have managed storage behind it, where we basically tiered the storage to S3. So we give you an opportunity to basically scale and pay for compute and storage separately. And that is very important because on one hand, with the shared nothing model that Redshift has had, we've always been able to give you the best performance. So that's one of the reasons why Redshift has been the most performant data warehousing solution, is we've embraced that model. On the other hand, though, that shared nothing model meant that as you were scaling up either compute or storage, you also had to pay for the other piece. So with the new RA3 instances, we let you scale these things independently. And part of the secret sauce here is we have very sophisticated algorithms and data movement and data placement where we really don't have to move a lot of data over the network most of the time. That's both because we do it at a very granular level, we're doing it very intelligently, and we have super big local SSD storage. And given that customers, you will usually not touch all of your data all the time, it basically means you're going to be cached locally, pretty much most of the time. And just for existing Redshift customers, this is giving you great performance. Like if you were on the dense storage nodes, you basically get, for the same cost, 2 times the storage that you had before, and you get up to 2 times the performance on these instances. And we can scale right now up to 8 petabytes of compressed data. And I would say average compression is probably about 3.5x or so. So it just kind of gives you an idea on how much data we can actually analyze for you. Now, this kind of this interesting thing where we say, hey, RA3s are so great, but we think we can do better. And so as we were working on RA3s, we also felt like, compute and storage separation is really cool, and there's a lot of value we can deliver today, but the reality is it's not really the right thing for the future. Because in the future, your data scaling a lot more, that risks more data having to go through the network. We do have great networking, but it's still, there's still a limit. And then, as Andy talked about yesterday in the keynote, network bandwidth, SSD bandwidth, right, has grown by 12x in the past 7 years. The CPU memory bandwidth has only grown by 2x. So our ability to actually process the data at the line speed that we're getting out of the SSD, right, is becoming very, very challenged. And so ultimately, in today's world, the way you could solve that is by scaling out more, buying more CPUs, but that would be very, very expensive. So this is kind of that other 10% I talked about before, which is how do we innovate on your behalf? And so that's where we announced Aqua, which is basically a multi-tenant tier that has purpose-built hardware. And there's 2 things that Aqua do. Before we talk about the purpose-built hardware, the first thing is it's just a scale-out environment. So we can actually process your query with more nodes than you actually have in your Redshift cluster. Just by that, we can get you much better performance. But the second thing is we eliminate the CPU bottleneck. We are actually processing this data at line speed by using AWS-designed custom processors that are designed to process data much, much faster. So a lot of exciting things around Redshift. What I'd like to do right now is actually invite one of our engineers on stage who's going to give you a quick demo of the spatial feature that we launched a couple of weeks ago.
Good morning. My name is Menelaos Karavelas. I'm a senior software engineer in Redshift. What I'm going to do today for you is show you some of the capabilities that we have in our spatial support for Redshift. So what you see here on the screen is a map of the city of Berlin. Underneath the hood, we have a Redshift database, a Redshift cluster that is running, and it has 3 tables, spatial tables associated with it. The first one contains 22,000 Airbnb locations in Berlin. The second one contains 190 polygons from the city of Berlin. These are the zip codes from the city of Berlin. And we also have another table, an external table of 11 million points of interest around the globe sitting in S3 in CSV files. And of course, all these tables do not just have geospatial information. They also have metadata, other metadata associated with it. So at the screen here, you will see at this bottom left corner some information about the queries that I'm going to be running. And at the bottom center of the screen, you're going to see the text of the query that I'm going to be running. And the buttons here correspond to different queries. So let's start with the first button here, which we call the accommodations button. What it does is that it queries the Airbnb location table and shows all the results that fit within the screen window, the bounding box, the viewing box of the screen that you see over here. And as I zoom in, or zoom out in this case, the results get updated. And of course, we limit the number of results to 5,000 for visualization purposes. Now, what happens if you click on one of those dots over here? You will see some information about the corresponding location that we've taken out through our query from the data we have in Redshift. There is the name of the location, the price, the name of the host, and the neighborhood. And you can see here different colors, and the different colors correspond to different prices of the locations. So the lighter the color, the lower the price. In this case, we have a quite expensive location in Berlin, priced at 6,000 euros. Let's move on to and here at the bottom of the screen, you can see the query. You can see that we have 4 special functions used here. There is the stx function, sty, a special predicate, st within, and there is also a function for ingesting a geometry from a wkt format. Let's move on to the next query. In this case, what I have to do is that I also have to click on the screen. And every time I click on the screen, I'm going to request all the locations that are within 600 meters from the point where I click on the screen. And again, as in the previous case, I can click on one of the locations and get information. It's exactly the same information as you saw before, but you can also see the distance from the point where I clicked on. And if I click on another one, you get the same information, and so on. And as I click on other places in the map, the results get updated every time 600 meters away from the point where I clicked on. Let's move on to the next button here, the zip codes. This is another query that is querying the other table that we have loaded into the database. This is the zip code tables that I was referring to. It consists of polygons. And these are the all the zip code polygons that we have in our database, the 190 zip codes of the city of Berlin. You can see here in the query text that we export them in GeoJSON format, and this is how we display it through the API that we have here, the client that we're using in this demo. The query by itself is pretty simple in this case, but this is really the preamble for what comes next, which is a choropleth query, which is typically known or can be referred to as a spatial join. So what we have in this case is that we have data from the 2 tables we've been discussing so far, the accommodations table and the zip codes table. What we do is that we locate each one of the Airbnb accommodations in the corresponding zip code polygon that it is contained in, and we compute the density, or the number actually, this is our density in this case, the number of accommodations per zip code. And we color code the map according to the density, the number of accommodations per zip code. So the darker the color that you see here, the more accommodations we have, the lighter the color as we go to the suburbs of Berlin, the less accommodations we have. And of course, you can use any other kind of aggregate function in this setting according to what would be your use case. Let me finish up with the last query here, which is actually a query that goes through data in S3. What we do here is that we consider the view box of the screen, this window here. We take, of course, the GPS coordinates, lat and long coordinates of the window that you see here, and we transform this into a polygon, and we query now the 11 million points table from S3. And what you see here is the results in 3,035 in this case. It takes a little bit less than 4 minutes. And as we zoom out, we can see more and more results. That's it for me. Thank you. Back to Andy.
Cool. Thank you very much. Nothing demos better than spatial. That's for sure. I'm going to move a bit faster, I see, and we're a bit behind on time, and I do want to get to the second demo. So most of you probably already know EMR. It's our managed service for lots of big data software, such as Spark, Hadoop, Hive, Presto. Really what EMR does is it takes away a lot of the heavy lifting and muck from having to set up these environments yourself. One of the features that I personally like most about EMR is that we actually we have spot support for you, so we can really help you drive down cost on your big data processing. We also have very good connectivity to S3. We've really optimized that, so you really get great performance and value out of the service. Some of the new things we've introduced, we just announced support for Apache Hudi. For those of you who are not familiar with it, it's an open source project that came out of Uber, has been contributed to the Apache Software Foundation, is in an incubation stage now, but it really helps you do upserts against the data lake. So you think about S3, it's obviously immutable from a file perspective, but even just for compliance reasons, sometimes you have to erase data. So what it helps you do is it actually helps you do inserts, deletes, updates on data in S3, and it basically manages the rewriting of the files, the tombstoning and so on, and the metadata around those files. So we're super excited about it. The project itself today already supports Spark and Hive and Presto, and definitely something that if you are using the data lake in a more intense way, you should be looking at solutions like Hudi. We also have continued to improve Spark and Spark performance. Spark is super important to us. And we actually have made 2.6 times better performance improvements just in the past few months. Compared to other managed services for Spark, we've also made performance improvements. We're about 1.6 times faster than other managed services, but we're at the 10th of a cost. So same thing translates here. Our focus on Spot, our focus on driving down cost, making big data affordable, really helps customers who's using EMR. Most of you probably are familiar with Elasticsearch, very useful in log analytics, whether that is application monitoring, infrastructure monitoring, security information and event management. It's a managed service. We basically also take away the undifferentiated heavy lifting for you, so make it easy to manage, to scale, backup and restore. We have a lot of features around security and compliance in the service, and you also pay for it on a pay-as-you-go basis. The big announcement we made yesterday around Elasticsearch was ultra-warm. So one of the key challenges we've seen with log analytics at scale is it's too expensive. And whether you're using Elasticsearch or Splunk or any other solution, the problem with log analytics is, A, you have a lot of logs and it just keeps on exploding. But number two is the way you use logs and the way you do log analytics is very interactive. So you've kind of got this problem where on one hand, it's very big data, but you also need an interactive experience. And so as a result, the kind of warm tiering that has existed to date in other managed services or that customers have done themselves in self-managed environments has just not been that good. Customers have used things like D2 instances, which are nice, but they just don't perform that well. You maybe get a 40% cost reduction out of those environments. We really wanted to change the game. So with ultra-warm, we innovated and really did heart surgery within Elasticsearch and built infrastructure to tier the data in a super optimal way. And there's a lot of innovation that went into that, both around the query processing and how we do very fine-grained data movement, how we know which data we should fetch and when, and we try and fetch data before you even know it has to be fetched. So we are doing a lot of exciting work there. And basically that allows us to drive down cost up to 90% on a per GB basis and up to 80% versus other managed services. So definitely something you should take a look at. It's in public preview right now. You don't have to be whitelisted. Next is Athena. Athena is a really awesome service based on Presto for ad hoc querying of the data lake. If you've got to do super large scale, complex joins and so on, Redshift will probably do it faster. But if you just got data in the data lake, you need something super simple with lots of SQL support. Athena is really, really awesome. You pay on a per terabyte scan basis, which is also one of the recommendations I gave you to make sure your data is in analytics optimized format, not in CSV format, and you will just get great performance out of Athena. The really cool thing we've done in Athena, and we're going to go to the demo in a second, is federated querying. Now, this federated querying is very different from the Redshift one. Redshift really has kind of looked at very bespoke systems like data lake and operational database. And the problem we're trying to solve there is the best performance at scale and less connectors, but do them really, really well for our customers, given the kind of nature of Redshift. Athena takes a whole different approach, which is really awesome, which is, everyone knows SQL. You got to stitch together a lot of systems. You need to have observability across your SaaS applications, your data stores, your S3 environment. But it's really hard to give data analysts kind of an easy way to get at all that data. So what the Athena team has done is they basically built federated querying based on Lambda and created connectors on Lambda that helps you in a single SQL statement bring together lots of different systems like Redis and Elasticsearch and MySQL. Actually, Elasticsearch is not there yet. We will add it, though. And we basically open sourced all those connectors. So they're on GitHub, and you can build your own connectors. So if you're using, Salesforce or Google Analytics, or you have lots of other kind of data sources, our goal is actually to build an open source community around these connectors. And basically, over time, you're going to be able to query any system using Athena. So without further ado, I'd like to invite one of our lead engineers in Athena onto the stage to kind of show you what this looks like.
Hey everyone, my name is Anthony Virtuoso and I'm a principal engineer with Athena. So I'm going to walk you through some of the examples of how Athena federated queries can help you break some of those data silos and how Athena federated queries are really complementary to your data lake. In a moment, we'll go through an example e-commerce company architecture that has its data stored in 8 different data stores, each one specifically picked to align with the business task that particular service needed to enable. So with Athena federated queries, you're able to combine data in your traditional data lake with some of the other information that may be more difficult or challenging to get into a data lake, whether that information may be transient, meaning that it only lives for a short amount of time as state in your application, or that data may have a very high mutation rate that is either costly or challenging to get into your data lake. So let's take a look at this example architecture. And for a moment, imagine that we're an operations manager responsible for keeping this e-commerce company running smoothly. By most measures, one would say that this architecture is fairly well designed. The team broke down the responsibilities into different microservices. Each of those microservices is in its own VPC to improve its security posture. And as I mentioned before, each of those different services was free to pick the data store that best enabled their use case. Let's take a look at 1 or 2 of those real quick. So on the top left, you'll see a payment service. The goal of this payment service was to be able to support the company's high transaction rate. They were interested in a data store that was able to support a very high write rate, as well as have long-term retention. And so for that, they picked HBase on S3 because it is a write-optimized data store. Similarly, for their order processing service, whose primary job was to provide a low-latency interface to the other parts of their infrastructure about which orders were open, which orders had been shipped, and just their general state, the team picked Redis on Elasticache because of its all-in-memory and low-latency access. Our next service on the bottom left is the personalization service. And this team was challenged to enable the company's global strategy by being able to support varied definitions of what a customer or their shipping address would be globally. So that means different fields for different countries. And so to enable their NoSQL access pattern and schema on read, they elected to use DocumentDB. So if you remember from before, I said we're the operations manager for this architecture. And it just so happens that we've been getting an increasing number of customer reports that orders are in a stuck state. So with an architecture this diverse and that many different data stores, how do you begin to troubleshoot this? How do you know the scope of impact? Are there 2 orders affected? Is it 1 million orders that are affected? And most likely, you're not an expert in every one of these systems, so how do you begin to do root cause analysis? So with Athena federated queries, one of the things that we can do is, with a single SQL statement, we can run a query that will span all the applications we just talked about and give us a very quick and up-to-date operational view of our system. So I'm going to run one of those queries, and then I'll walk you through the different pieces of it. So the first thing that we do in this particular query is we're saying that we want to query CloudWatch logs. And in particular, we want to query the log group that's represented by our order processor. And we're going to query a special table provided by Athena's CloudWatch connector called the all log streams table. As the name suggests, this is literally going to query all the log streams from our order processor log group. And I'm doing a couple things with this query. The first thing is I'm extracting the log level from the log line. And I'm saying I don't care about informational things. Presumably, all I want back is warnings and errors, things that are anomalous. I'm also then doing a regular expression to extract the order ID from those anomalous log lines. Because the next thing I'm going to do is I'm going to join any of those anomalous log lines with information from our Redis instance about active orders. So this is going to now give me all the active orders that had some kind of anomalous log line for them. Once I have the orders that are affected and that initial log line that may indicate a problem, the next useful thing to do would be for me to figure out which host processed that order so that I can go and take a deeper look at the contextual logs. So the next thing we end up doing is we use Athena's CMDB connector, stands for Configuration Management Database, to actually run a query against our EC2 hosts, get back the list of EC2 hosts, and combine that with that information we got from CloudWatch logs to say, these anomalous orders were processed on these hosts. I won't go through all the rest, but then we end up joining with DocumentDB, as well as our payment database in HBase, in order to just bring more contextual information in for troubleshooting. So I'm going to go ahead and run this query. And if the demo gods smile on me, it'll work. I think usually the query ends up taking about 10 or 15 seconds. And so what's happening here is Athena is actually reaching out to several Lambda functions in my account. Each of those Lambda functions has code deployed that knows how to talk to the source system, translate it into Apache Arrow, which is Athena's preferred interchange format, and then it'll give those results back to me. So what we can see on screen here is that we did get a few results back. As I mentioned, we have some of that order information that came from Redis. I've got some of the customer's contact details that we pulled from DocumentDB. I have some of the payment information that we got from HBase, as well as some shipping details that were stored in DynamoD in this particular case. And if I scroll way over to the right, I can actually see that we do have two orders that generated anomalous log lines. In one case, it was an error. The other one was a warning. And the interesting thing I can see here is that both of those impacted orders went through the same EC2 host. Right? So really quickly, in about that 15-second period, I've now identified the fact that I've only got two orders impacted, and the interesting fact that they both were processed on the same host. So I may want to proactively just go and take that host out of service while I investigate. I didn't have to go to all 8 systems to gather this information. Now, certainly, I did have to deploy and set up these connectors, and I'll just briefly kind of talk to you through that. So one of the things the Athena team has done, and as Andy mentioned, we're hoping a community will grow around this, is that we've authored and published 10 connectors and made them available in GitHub. But we've also published them to serverless app repo. So you can very easily navigate to serverless app repo in the AWS console, search for Amazon Athena Federation, and you'll get back a list of 10 or so connectors. You'll also be able to see that we have an AWS verified author tag. Anytime you see that, you can rest assured that the connector you're about to deploy is written and maintained by the Athena team. And with that, that kind of sums up Athena Query Federation. We're pretty excited to see what you guys do with this, especially with the SDK. And I'll hand it back over to Andy.
Great, thanks a lot. I think this is super exciting, and if you have your own little bespoke system sitting somewhere, and you're trying to figure out how you basically expose that system to others, you can also just build your own little connector that will expose that. So we are super excited about it. Last but not least, QuickSight. I did want to touch on QuickSight. QuickSight is our BI service. What I really like about QuickSight is it's serverless, super easy to use. It's on a pay-as-you-go basis. It's very, very cost effective. It's $5 per month for readers, $18 per month for writers. And so, our goal here has really been to democratize BI within the organization. As we talk about democratizing insights, you may have users who want to, buy a very specific tool. For example, business analysts are used to using certain tools, but there's really a non-consumption opportunity where there's lots of employees who just don't have access to these tools. and so on. So with QuickSight, we've tried to make it as easy as possible to get that access. We have quite a lot of organizations using QuickSight to kind of democratize that access. Capital One has chosen it to enable tens of thousands of their employees to be able to get insights. Best Western Hotel is looking to roll it out to 40,000. And then we're using it for lots of things across Amazon. And why did I put Amazon up here? Because when we announced QuickSight, I think it was in 2016, November 2016, it was okay, but it wasn't great. And even internally, a lot of our users didn't actually want to use it. They were using other stuff. It's really come a long way. Like if you haven't looked at it for a while, you should. It's pretty awesome. We've also done a lot of machine learning now, so we do things like anomaly detection and predictive charts. So we've really tried to use the power of the cloud to really bring things into QuickSight that are very unique to QuickSight. So definitely worth giving it a spin. And as I mentioned before, it's a super low price point. The one thing as a developer that I really like about QuickSight is not just a BI tool. We actually help you do embedded BI. So if you're building an application, but you need a BI kind of reporting piece in that application, you can actually embed QuickSight into your application. And we've done a couple of things to make that much, much easier that we've announced over the past few weeks. The first thing is everything can be API driven now. So as opposed to you having to visually, build your console, build your charts, as you want to build them into your application, you can actually programmatically define what those charts are going to be and start to embed analytics into the applications you're building. The second thing that, of course, comes with that, which is critical, is theming, where you can actually make QuickSight now look like your application, so it feels very, very native to your customers. That's pretty much what I had on analytics. So as I kind of opened up, our goal is to help you, democratize insights within your organizations, really make sure that you can increase revenue, increase profitability, decrease risk by being a digital-first business. And a big focus of ours is helping you rationalize the data, rationalize the data scale, make sure we help you manage your cost, because that is, of course, a big challenge with this data explosion. And then, make sure that you can do that in a way that, on one hand, breaks down the silos, enables all the people in your organizations, but in parallel, makes sure you can be secure and you have good governance around your data access. So we have about 2 minutes left. I'm more than happy to take questions in those 2 minutes. I do apologize that after 2 minutes I'm going to have to run, because I have to run to a different meeting. But if there are any questions here? Okay, no questions. I'll hang out. Yeah, go ahead. Okay, the question is, how would we compare Redshift to Snowflake? I haven't used Snowflake, so I think, I'm probably not the best person to ask. And we're super customer obsessed. We're really focused on our customer base. Snowflake is a good partner of AWS. But, Redshift has a huge customer base, biggest cloud data warehouse. And a lot of what we do is really kind of just working back from customers. And there, you'd have to make your own determination, what is the right fit for you. Okay, the question was, what is the difference between Redshift and Athena? That's probably a long answer, but very, very simply, Redshift is a full-blown database, meaning it manages the storage, it manages the indexing, and so on and so forth. Athena is a query engine, right? So you have to figure how you get your data there into the system. With Athena, you have to do that with Glue or other systems, right, to index your data in that way. Redshift is a full-blown data warehouse. I think the way I would think about this is, if you really need to do a lot of complex querying, a lot of complex BI, and so on and so forth, you're going to get the best performance with Redshift. Order of magnitude better performance, right? But if you've got just lots of stuff in your data lake and log files and clickstream data, and you just need a simple way to query that data, do some simple joins and so on, Athena is awesome. So I really like both services for different reasons, so it really depends on the use case that you have.
One quick question.
Yeah,
So we got S3 at the bottom.
yeah,
On top of that, we will put Redshift and we can just the data from S3 to Redshift
yeah.
data. Or do we go towards the lakehouse kind of model?
Okay, so the question is, you know, you have S3 at the bottom, so we kind of have two things we're talking about. One is we can query from Redshift the data lake directly in the data warehouse, or should we do ELT and ingest some of the data from S3 into the data warehouse? And the answer is it depends. A lot of our customers will do ELT for specific data because they need it in the fastest format, and it's not necessarily that huge. And so we see a lot of ELT workloads using our data lake access to bring some of that, transform it on the way. But then we also see situations where, you know, if you have a few hundred terabyte or maybe petabyte in a data lake, it may not make sense for you, right, to bring that data into the data warehouse. So you kind of have to make that decision. It very often depends on the data size and what you need to do with it and how frequently you need to query it.
For the large data sets, just use the
I would say if an ultra-large data set you're not querying that all the time, but using it to get the big insights, I think you can leave it in the data lake. A lot of our customers have SLAs around the queries, around business data and revenue reporting and so on, and they're going to want to bring it into Redshift. Okay, how do we manage security across these? You know, Lake Formation is one way to do that, where we help you secure the data on the data lake, and then we honor that security configuration in Athena and EMR and Redshift. Redshift also has its own security model. What we're doing over time is we're trying to make sure we start unifying the security model, so using IAM and using, you know, Active Directory Federation to make it easier. We're not 100% yet where we want to be, but that is a huge area of investment. And I apologize, I actually do have to go. I do have my email up there, by the way, so feel free to take that down and send me an email.